Optocoupler. Symbol optocoupler. The optocoupler symbol used in circuit diagrams indicates the function and internal elements within the overall component. The symbol shows the LED, which is normally used as the light emitter. The optocoupler symbol also shows the receiver of the phototransistor or photodiode, although other devices including light sensitive diode etc. may also be used. The relevant device type is shown within the optocoupler circuit symbol. Here we have 6 types of optocoupler symbols, which is optocoupler, optoisolators, diode, semiconductor, two-way optocoupler, optocoupler diode, diac, encapsulated optocoupler diode, transistor, optocoupler diode transistor, then optocoupler encapsulated diode transistor with hollow beam for cutting. How does an optocoupler work? An optocoupler, as shown in figure 1, consists of an input LED, a receiving photodetector, and an output driver. The driver circuit and LED circuits are typically built using complementary metal oxide semiconductor CMOS technology, with the insulation or isolation barrier usually consisting of molding compound. Both the input and output of an optocoupler isolator require separate voltage supplies connected through the anode and collector pins, and separate grounds typically connected at the cathode and emitter pins in order to maintain signal isolation between the input and output. Graph the V against I characteristics curve of the optocoupler. This ratio is enhanced with an ideally matching IR LED signal spectrum with its adjacent phototransistor detection spectrum. CTR is thus defined as the ratio of output current to input current at a rated bias level of specific optocoupler device. It is represented by a percent, which is CTR equals to I dash if times 100%. When the specification suggests a CTR of 100%, it refers to an output current transfer of 1 milliampere for each milliampere of current to the IR LED. Minimum values for the CTR may show variance between 20 to 100% for different optocouplers. The factors that may vary the CTR depends on the instantaneous specifications of input and output supply voltage and current to the device. Graph the V against I characteristic of optocoupler. The figure above shows the characteristics plot of an optocoupler internal phototransistor output current ICB versus input current IF when a VCB of 10 voltage is applied across its collector or base pin. V against I characteristics curve of optocoupler. An optocoupler can be used as a functional device indicating the current control type negative resistance characteristics controllable with 2 external light intensities. A new type of light detecting circuit using the presence function holds the ability to detect both the incidence of a light intensity and the small change from the fixed intensity level as a shape pulse light output with a simple circuit configuration. Consists of an LED that produces infrared light and a semiconductor photosensitive device that is used to detect the emitted infrared beam. Both the LED and photosensitive device are enclosed in a light tight body or packaged with metal legs for the electrical connection as shown. Let's look into the turn on characteristics of optocoupler. When the LED is driven with a current of 10 milliampere or so, it shines onto the phototransistor, which then starts to conduct turn on. This takes the output voltage low. However, much electrical noise is one on side, it can never be transmitted over to another side. Finally, turn off characteristics of optocoupler. This device basically works like a switch connecting two isolated circuits on your PCB. When current stops flowing through the LED, the photosensitive device also stops conducting and turns off.